Thank you. Good afternoon. My name is Sim with the Energy Management Association, and I'd like to welcome you to today's webinar, Carbon Goals Start Now, It's Easier Than You Think, and thank the National Insulation Association for sponsoring today's session. A few items before we get started. Presenters will be holding questions until the end of presentation, but we encourage you to submit them at any given time using the Q&A button. If you happen to be experiencing any technical problems during the webinar, please use the chat function to inform the panelists, and our technical expert, William, will assist you. This presentation is being recorded and will be available for viewing in 1 week. In terms of the CEU, that is the Continuing Education Credit, everyone in attendance for the full webinar will receive a certificate of attendance sent to their email within 24 hours. And finally, if you are certified CXA or EMP, your CEUs for attending any webinar in the series will be automatically uploaded to your respective portals. A little about Jack. Jack Bittner, Senior Product Manager at Johns Manville Industrial and 2024-25 AIA President, holds over 45 years in the insulation industry. He began as an insulator with Brown & Root and then advanced through roles at Thor Product Company before joining Johns Manville in 1991. His journey at JM has seen him in various positions, including Sales Territory Manager, Market Manager, and Vice President of Marketing. Bittner holds a Bachelor of Business Administration from the University of Houston and an MBA from Lamar University. Thank you again, everyone, for joining us. And with that, I'll hand it off to our expert, Jack, to kick us off. Jack, take it away.
Thank you very much. I don't need to say any more. That was a complete introduction. I appreciate it. So I'm here to talk about, and I must apologize, my screen is not advancing again. Hey, Aaron, maybe you could share your screen while I try to figure this out, and I'll keep talking.
Absolutely. Give me one moment.
Yeah, mine just locked there, and I apologize, everybody. We did testing of this for a half an hour a little bit ago.
Worries. It looks good, Jack. So.
Okay, could you advance?
Yep.
Oh, wait a minute. I'm still sharing, aren't I?
Yeah, you're sharing.
Okay, you can take it. All right. So I'm here to talk about insulation and how it relates to carbon goals. I've been in the insulation business pretty much my whole career. And one of the struggles I've always had is we all know insulation, whether it's industrial insulation or mechanical insulation or whatever it is, contributes significantly to reducing energy loss and is also carbon reduction. It helps everything run at the temperatures it's supposed to run at, and also provides personnel protection. But everybody seems to not pay much attention to it. In addition, the folks who did know a whole bunch about it, like when I started in the business, the folks who trained me and mentored me, they're all retiring and getting out of the business. And that's happening to me too. I'm 67 years old, so the knowledge base is getting reduced, and that's further leading to underutilization. In addition, systems are being applied and supplied, but rarely engineered. We've preached this for a long time. Insulation should not be an afterthought. And then when the project gets going, insulation ends up getting value engineered into a different product, not the one that was originally designed into it, and that was designed into it for a reason. But insulation is typically a very small part of a larger contractor, particularly when we're talking new construction. And by the time you get to the insulation, the project's behind, the owner's running out of money, and folks are pushing the insulators to, okay, so what can we do here? We got to go faster and cheaper. And then the performance suffers when that happens. The other part of it is there's no gauges, you can't see what it saves. There's no monitoring, there's no computer chip, there's no app you can put on your phone like you can for your solar panels on your house to tell you how well they're working. And insulation, it's been around for literally thousands of years. It's not shiny, it's not new, it's forgot. People just don't pay attention to it. But the benefits are instantaneous and they're continuous. They never stop once you insulate that piece of equipment or pipe. It works as long as it's there and as long as you maintain it. Did you move, Aaron? One of the other problems is we all know that, but how do you quantify how much insulation is really going to help you as far as energy reduction and emissions? We've all known for years that, yeah, well, it probably does this or maybe does that. And there's never been science and hard numbers. But last year, National Insulation published an energy and emission study, and this was a 2-year project. It studied the US and Canada, commercial building, and is also industrial insulation as well. And it calculated how much energy is saved and greenhouse gas emissions are reduced with the use of insulation. And this one also not only looked at new construction, but also under-insulated areas in particularly the higher temperatures is where it's much more significant. Those are common. And, you ask people, how much of your facility is under-insulated or not maintained and poorly insulated, and you'll get, depending on who you're talking to, you'll get an answer from, 10%, 15, 20, 25. Nobody really knows. But in this study, it included reporting from 4 major manufacturers of insulation in North America: Johns Manville, Knauf Insulation, Owens Corning, and Rockwell Technical Insulation. And what they did was they actually reported numbers by pipe size and thickness, linear feet that they've sold in the various insulations, whether it's fiberglass or mineral wool or other industrial insulations as well. And also square feet of boards for insulating, where they insulated the sides of equipment and pressure vessels and that sort. And then calculations happened. Once you had that hard data, and this was reported over a 5-year period by each of those manufacturers. Now you got hard data, and you can back into, based on temperature, operating temperature, and different insulation thicknesses, how much energy is actually saved and how much emissions are actually reduced. So this is a study. There's a QR code at the bottom of this slide. This is a study. It's 53 or 54 pages, and I'm not going to go through it because it's very detailed, but you can get access to it and read through it. What I'm going to start with is I'm going to focus on under-insulated and under-insulated areas because new projects are going to be insulated anyway. So they're going to be updated in terms of the codes. It's going to be current practice, current specifications, but under-insulated areas or uninsulated areas are different. They may have been installed 15, 20 years ago. Specifications change, codes are updated. Insulation gets damaged. You look at some of these pictures and people walk on it, they sit on it, they stand ladders up against it. They work it over pretty good. And when insulation gets damaged and the thickness is reduced, you're not getting the performance that it was designed to give you. And there's always been a lack of maintenance. Folks don't look at insulation as something that needs to be maintained. In some of these pictures, you can see it was a matter of convenience. They took the insulation off the elbow there in the top right so they can have access to the bolts to remove when they have to open up that flange. In the bottom right, you can see hanging off that one pipe where the insulation is damaged, there were insulation pads, removable covers, that were removed for maintenance, and they've been there a long time. So they were taken off. They're designed to be removed and replaced, but these were removed and hung on the pipe and never replaced. This is not uncommon. And then there are also sections of pipe and equipment that aren't insulated in the first place. And why would that happen? There's a lot of reasons. One of them is in facilities like power plants or petrochemical facilities or even some commercial facilities. There's concern about corrosion under insulation. And this happens at a fixed temperature range, generally the lower side, 150 degrees Fahrenheit up to 350. And the concern about corrosion is so great that they don't insulate it because then you avoid corrosion under insulation, and they'll put standoffs to keep people from touching it and getting burned. But there are insulations around today and coatings for pipes that really do go a long way to reducing corrosion under insulation for those types of applications. And rather than having a standoff and let all that heat and all that energy go into the air and generate it in the first place, to have it go into the air because you're worried about CUI, you don't have to do that anymore. You can actually insulate that pipe or that piece of equipment and not worry so much about corrosion under insulation with some of the new technologies that are around today. So this slide is I actually took this out of the presentation or the study, and it is the cost that was calculated for under insulated areas. And the study, as you can see here, I'll explain a little bit of this. It looked at the current year, which was based 2022. The study was actually completed and published in 2023. But then it looked back 5 years and forward 5 years for an 11-year window. And I am just going to, rather than get overly complicated with that, I'm just going to study on 1 year, just 1 year, which was the base year 2022. So the bottom line is, if all the under-insulated or unmaintained areas of facilities were actually insulated, in 1 year alone, the combined total savings in dollars was $2.5 billion. And this is sitting there. It's available for use, and we've got studies or we've got insulation appraisers who can go do energy audits and tell you, if you do just insulate this 6 feet of pipe, this is the return. That valve over there, this is the return. And you can document what you can get. And we've been doing this for years. This is not anything new that the industry's had. But we talk about, go back after we do the study and say, hey, look, you can save this much over here. The payback is 3 months. The ROI is this. It's there. Once you do it, it keeps performing year after year after year. And it just, amazingly, people don't do it. Could you advance, Aaron? So what's the problem? We all sit here and we scratch our heads saying, man, this is like right here. All you got to do is do it, and it pays immediately. So what's the problem? Well, I think there's two possibilities. One of them I've been preaching for years, and I know nobody's going to change your accounting practices and all that, but the difference between an asset and an expense. People view insulation as an expense, and expenses are pretty much short-term, one time. You do it once, it's over. However, an asset helps a business derive economic benefits in the future. That sounds like insulation. And provide long-term and short-term benefits. That sounds like insulation too. If you insulate this 8-foot section of pipe, it'll save you $2,500 a year, and that's year after year after year. That sounds more like an asset to me, but, and again, folks aren't hearing that, and that's just not common practice. And I know many of us, our own facilities, don't view it as an asset, but it's just been a pet peeve of mine for years. But we do have ways to tell you, to quantify what fixing that section there, repairing that damage is going to do and save you now and in the future. So that's one of the issues. The other one is, I think nobody's paying attention to dollars. Could you advance, Eric? We've been talking dollars for years. So maybe we've been using the wrong bait. So let's look at this one again for base year 2022. If all the under-insulated areas were insulated, it would save $2.5 billion. And nobody's listening to that. Maybe, could you advance, Aaron? We should start talking about carbon. And just so you know, when we do an insulation, when you get an energy insulation appraiser into your facility to do an audit, the report includes payback, ROI, dollars, economic thickness, the best thickness you should have that insulation. And then at the bottom, it talks about, oh yeah, and it saves this much carbon. But that's always been an afterthought. But more and more, carbon is getting to be king. And I think it might be a new currency as we go forward here. So the U.S. has carbon goals. If you go back, Aaron. The U.S. has carbon goals, and one of the one is to reduce our carbon emissions in America by 45% by 2030. Well, we're halfway through 2024, so that's not much time left. It's about 5.5 years. So in order to do this by 2030, reduce it by 45%, we would have to take out 2.47 billion metric tons of carbon by 2030. By 2050, the numbers are astounding. But the bottom line is, we don't have the technology to do this right now. It doesn't exist. It's a great goal, but we don't have the technology to do it. And we've allocated as a government and our own companies billions of dollars to do it, but the technology doesn't exist. Could you advance, Aaron? Yeah, we've all got the green paths to reduce emissions, the green energy, solar and wind. That probably includes a battery backup at some point. Geothermal, hydrogen, hydroelectric. And if you look at these projects, we've only got 5.5 years left. So to reduce it by what we're talking about, some of these projects aren't going to be anywhere near complete by 25 or by 2030. Next slide. The challenges are huge. Just the approval process and construction cycles for some of these projects, and simple ones like windmills, take a long time. They don't happen tomorrow. Meanwhile, you can insulate that pipe over there this afternoon. They take significant capital. Some of them, the technologies are still being developed. We don't have them yet. And some don't provide 24/7, 365-day solutions. So we talk a lot about, oh, you can plant trees and get this much carbon reduction. Well, a tree, you plant it, it's not contributing to the carbon according to the formulas I looked at and the different models. They figure that tree's got to be 10 years old at least before it's actually doing what it's designed to do as far as reducing carbon. 10 years. Insulation, do it today, you got a 10-year head start on that tree. Windmills, similar deal. It takes up to 4 years to get a windmill permitted, where's it going to be, built, and actually running. So insulation now over a windmill has about a 4-year head start. And insulation lasts for the life of the system. Meanwhile, the windmills are good for 25. I've seen numbers from 25 to 30 years. And trees depends on, I don't know what the survival rate of some trees when you plant a whole bunch of them are, but the insulation's there. It works day after day after day. So it keeps contributing. The quick answer is install insulation. We have it. It's here. We know it works. It's been around for thousands of years. Yeah, it's glamorous and it's dusty, or not glamorous and it's dusty. And here's a guy taking off. He's actually doing maintenance on some rooftop ductwork, taking off old wet insulation and installing new ones. But it works now, and it keeps working. Next. Oh, yeah. And you also get carbon credits. Those are becoming a bigger and bigger deal. So when you install insulation, you reduce your carbon, you can actually begin to accumulate carbon credits, which gets to be free money as if we look a little bit down the road. Next one, Aaron. So insulation, I mean, I've been, to prepare for this presentation, I looked at all kinds of things on the internet of people recommending, here's what we need to do to get to our carbon goals. Technology to remove CO2 from the sky and the atmosphere by putting some up there to reflect the sun out into space. Another group wants to build vaults to bury trees under the ground so they don't release CO2 as they decay. And some of the crazier ones I saw was there's a group advocating for a mandate on a global ban on having children because each human has a carbon footprint. Another guy says, well, let's just genetically engineer smaller humans to reduce the footprint. And then they want to eliminate, some want to eliminate beef, and I'm, no way, man. I like a steak too much. Just insulate your pipes. It's here. It's technology that exists. We have it. Next. So everybody's looking up to the sky, waiting for something shiny and new to fall out of it that doesn't exist yet. While we're standing on savings from insulation that the benefits already exist. They're proven. They're here. All we got to do is do it. And they're walking over dollars while they're looking around for something that we just won't have by 2030. And if we're serious about doing this, let's start talking about insulation's impact on carbon emissions. So that number was actually in this column. We've been talking about the dollars, and that's all everybody first talks about. But look at the bottom. So the combined total of insulating those under-insulated areas, and I'm going to round this up, is 68 million metric tons. That's not insignificant. Next one. So let's take that 68 million metric tons. And that's just a year. And that's the equivalent of 14,000 windmills. So there's only about 9,500 windmills in the US today operating anyway. So you could either insulate the under-insulated areas or build 14,000 more windmills, but it takes 4 years to do that. That's right. So now we're like looking at 2028, where it's just to reach the goals. Let's just start with what we know. Yeah, do this other stuff, but insulation, you can do it now. So by 2030, if you insulated every year, those under and uninsulated areas and the damage, insulation gets damaged all the time. That 68 million ends up to, by 2030, if you start today, 476 million metric tons. And that equates to about 98,000 windmills. This is easy. It's here. You don't need a permit for it. Next one. So I mentioned carbon credits a little bit ago, and carbon credits are generally created by governments to limit the amount of greenhouse gas organizations can emit by placing a cap on them. And you've heard of cap and trade, and there's actually a market for carbon credits. And the way it works is a company that brings its overall emissions below what's required by the law can actually either keep them or sell them to other companies. So a carbon credit one carbon credit equals 1 metric ton of CO2. And the value of these credits depends on where I look, but I was seeing in 2023 from 40 to 80 bucks a ton. So if you look at the 2023 bar on this bar chart on the right, and then go all the way out to 2030, carbon's king, man. And this is starting to look like, if these dollars are real, from what I was able to research, this might be the new cryptocurrency as we move forward. It's going to be a big deal. So how are we using the wrong bait? When we do an energy appraisal and go in and talk to the owners or submit the reports, you know, we talk about the dollars. Insulation projects are low cost. The execution is really weeks instead of years, which is some capital projects are. The payback is less than a year in most cases. Sometimes it's only a few months. And then down at the bottom of the report, it says, oh, all design thicknesses are designed to reduce carbon emissions by 88 to 98%. But we talk about the carbon part as an afterthought. So let's look at the next slide, Aaron. Oh, okay. So we now have quantified actual data from that report to support the facts that insulation does actually reduce carbon, save energy. You know, the cheapest energy is the energy you don't generate in the first place. And proper insulation helps you do that. We certainly have plenty of tools available today to help quantify both the dollars, but also the carbon reduction. There are certified energy appraisers certified by the National Insulation Association. There's some really good software to do the calculations based on some of the data you get when you go out to do the appraisal, which will give you the answers for the carbon reduction as well as the dollars and payback. We've got a carbon savings technology that actually exists in insulation. Yeah, it's not pretty or shiny, but it's here and it works. You can do it tomorrow and you don't need a permit. You don't need any of that stuff. Just do it. So these are dollars that are plentiful and laying on the ground, like leaves in the fall, and we're walking over them looking for something else, but it's here. We can do it now and actually take some steps toward the 45% reduction by 2030 or the net zero by 2050. Insulation alone won't do it, but you know what? Nothing alone will do it. It's going to take several different technologies and options. There is no silver bullet. In addition, we offer the opportunity to collect some carbon credits and put some in the bank. Next one, Eric. So what are the next steps? Now that we have data in the form of that study, which for the first time actually quantified what we're talking about, as an industry, we've got to start talking about this with more than just ourselves. We've got to raise the visibility of the value of the carbon credits you can get from insulating anything that's not only just anything that needs insulated, you should insulate it. It's not expensive, and it starts paying back as soon as you do it. And very soon, these carbon credits, I really think, as I look to the future, might turn into some kind of form of the new cryptocurrency. They're going to get expensive. And if you've got some in the bank, you're going to be in pretty good shape. So share your successes with others. The tools are here to prove it. There are several certified energy appraisers and inspectors already scattered around North America, and there are classes offered a couple of times a year to get, and we're graduating more appraisers and inspectors every year. Next one. So there are strength in numbers, and I think if we all do this together and start talking about it, we can change insulation from the dirty, dusty material that nobody wants to look at, everybody wants to ignore, but it's actually a way to start taking real steps toward a reduction in carbon. And these are links to the NIA website for appraisers, energy appraisers, if you want to find one or be one. Insulation inspectors, the same thing. And then that study, the energy emission study that I started this whole talk with, is available on the website to download too. And that's insulation.org. So that's what I have. I think I talked fast, but we're ahead of the game. So,
Sure.
Questions?
Thanks so much, Jack. We appreciate you taking the time to go through that information for us. For those who don't know me, my name's Erin Penberthy. I'm the Senior Director of Education and Events here at the National Insulation Association. If you have any questions, feel free to drop them in the question box. We do have a couple. I'll start with Jack. The first one is around the insulation study. Can you talk a little bit more about the temperature ranges that were included as part of the study?
Yes, yeah, and I didn't mention anything about those. So that's a very good question. Where do you start with something like this? We're talking, you insulate from anything from chilled water and cryogenics all the way up to 1200 degrees Fahrenheit in an oil refinery or a power plant. So what did we look at? We couldn't look at that whole wide range, so we kind of narrowed it down to 150 degrees to about 600 degrees, which are, the higher ends where you're going to see more payback and more energy savings and emissions reduction. And it's kind of a sweet spot, but it's conservative because, like I just said, you insulate pipes from, chilled water, cryogenics, all the way up to 1200 degrees. So this is a small portion of what's actually the opportunity is. So the numbers I've been talking here, they are very conservative, but that's where the study focused, 150 to, I think it was about 600 degrees Fahrenheit.
Great, thank you. And can you explain the difference again between a ton and a metric ton?
Yeah, they are confusing. They're not the same. Basically, a ton's 2,000 pounds, and a metric ton's about 20% more than that. It's about 2,200 pounds.
Great. Thank you, Jack. We also got a question. Does NIA have a list of certified appraisers or companies that have certified appraisers? We definitely do. Going back to this slide, if you check out the link insulation.org/find an appraiser. That gives you a list. You can search by company, you can search by state. That lists all of our appraisers there, and that's the same for our inspector members as well. So you'll see that link here, but that's a great question.
Thanks, Erin.
And then one other question that we received is carbon credits. I know you talked a lot about this. How do we start with this? Where would you recommend starting if someone's trying to get a hold of those carbon credits?
Man, there's actually, I'm not an expert on carbon credits, I must admit going into this. But there are things like carbon credit banks. There's consultants you can get to help walk you through this. Some of it, because it's run by governments, gets pretty complicated, and there's procedures you have to follow and the whole thing. So kind of like Social Security or Medicare, there's people who you can retain to help you navigate that labyrinth, and they exist. Again, these carbon credits, I just think the value of them is going to continue to increase year after year because folks are struggling to meet the goals of 2030 and 2050. So I don't know how else we're going to do it, because I don't see any big brainstorms coming. New technologies come on the market every day, but if we're looking at these deadlines, buying and selling carbon credits is going to be a key part of the whole thing.
Thanks so much. And then the last question I have is, can I get a copy of the insulation study that you referenced during this presentation? Is that free? Where can they access that?
Actually, it is free. And that QR code, I don't know if you can go back or we want to show it again, Aaron, or just you've got that. Well, here it is on this. It's the green study on this slide. Go to that URL and it's free. You can download it. But again, it's just like 50 some pages. It's not, if you don't have a good internet, it might take you a little bit. But it's very, very comprehensive.
Great. Thanks so much, Jack. I'll throw it back to you, Sim, and close us out for the webinar. All the questions I had. Yeah, so that's all the questions that we received. I know there was one other comment that I got about carboncredits.com, I guess is a good place to look into information for that.
Yeah, there's a lot of
that's what one of the
websites.
attendees said. Yeah, thank you
Yeah.
for sharing that, Ronnie. We appreciate
That's
that.
a good one.
Yeah,
Thank you.
that's great. But we appreciate everyone's time today and for logging in. Again, I saw a couple questions come in. There will be copies of the webinar and the recorded link sent out after, so keep an eye out for that. Sim, do you have any other closing comments you'd like to mention before we log off today? No? All right. Well, thank you everyone for today's presentation. We appreciate you logging in. Here's some more information about the next webinar hosted by EMA that's coming up in June.
Thank you so much. And yep, before we wrap up, any other questions, any last minute questions? And I see, what do we need to get to get the credit for attending the webinar? Richard, the credits will be uploaded to your portal within the next 24 hours. So that should answer the question. And thank you again, Jack and Erin, for a great presentation and discussion. And again, thanks to our sponsor, National Insulation Association. While we wrap up today's webinar, the next exciting event is the virtual operation and maintenance training. That's on June 5th and 6th. Earn a certification of completion, 8 credits, that's going to be 8 AIA LUs, and gain valuable insight to enhance energy efficiency and system performance. Registrations are now open, so make sure that you're going ahead and saving your seats. Also, the upcoming webinar on the list is on June 4th. That's going to be a unified approach to HVAC optimization and maintenance, which highlights the need to reframe HVAC optimization by focusing on efficiency, performance, and maintenance objectives, rather than just waiting for perfection. So we would definitely love to see you again on the next session. That's going to be either the virtual O&M training or the next webinar. And with that, we'd like to thank everyone again. Thank you, Jack and Erin again. You guys have a good day.
Thank you.
Thank you.